Hi, welcome to your first chemistry revision course, the first day. So I'm Velina and I'll be your chemistry tutor for the next few days. So this revision course consists of 3 sessions, today, tomorrow and Wednesday, each at 11 a.m. And we're going to be covering the topics that students struggle most with and understanding these fundamental concepts. Okay. So today we're going to start off by doing some work on, atomic structure and chemical equations. And so we're going to firstly understand what the atomic structure is, and then we're going to look at the periodic table, and then we're going to do some chemical equations. So if you guys have any questions, please put them in the question and answer box. And I will get back to you. And this session is 1 hour long, so we're going to finish at 12. Okay. So firstly, do people want to answer what A, B, C, and D are? Do people have any ideas? So you want to put your answers in the chat function and then keep the question and answer for any questions. Yeah. Well, that's brilliant. So I can see some people have put. Yeah, great. Brilliant. Okay, so there's been really good input. So now let's go to see what the answers are. Brilliant, lots of great answers. Okay, so yeah, perfect. So here we have the electron, which is circles around the nucleus. Here we have, of course, like we see the nucleus, which contains both the protons and the neutrons. Okay, so your atom is made up of protons, neutrons, electrons, and the protons and neutrons are found in the nucleus. Okay, so it's quite good to know the relative charges and relative masses of the particles making up the atom. Okay, so the relative charges of a proton is, the relative charge of a proton is 1. The relative charge of a neutron, as suggested, is it's neutral, right? Neutron sounds neutral, so the relative charge is 0. And the electron has a relative charge of -1. Okay, so then the relative masses, they're slightly different. So your proton has a relative mass of 1, neutron has a relative mass of 1, and your electron is really, really tiny. And so we can say it's 0 or 1 out of 2000. Either one is correct. So you can say that the relative mass of an electron is 0 or 1 out of 2000. So it's a lot lighter than your protons and your neutrons. Okay. Brilliant. So let's look at the periodic table. This periodic table describes all the elements that we know so far. Yeah. And so do people understand what all these numbers are telling you? Should we talk through what these numbers tell us? So firstly, what is an element? So an element is something that is made up of just one atom. Okay. So say O2. That is an element because it's only made up of oxygen atoms, and that's it. Okay. Does anyone? So then, what is a compound? A compound is something that's made up of more than one element. Okay. So, for example, H2O. It's made up of both hydrogens and oxygens. So that's 2 different elements that goes into our compound. Okay. So let's see. Do you have questions? So what chapter, this is right at the start of the AQA course. We won't be doing electrolysis, and there will be a Kahoot. Okay, so now let's understand what each thing means. So firstly, this top number is our mass number. So that is, like it says, the number of protons and neutrons in our nucleus. Okay, so this is the number of protons and neutrons, as you saw in the nucleus in the center of the atom. Okay, so this is our chemical symbol. each element has its own unique chemical symbol that describes the element. Then we've got the name of the element, and then here, really important number is your atomic number. So that is the number of protons in your structure, okay? So if you want to find out the number of neutrons in your atom, you need to do the mass number, take away, so the big number at the top, the mass number, take away the atomic number, and that gives you the number of neutrons, okay? So it's always the big number, take away the small number to find out your number of neutrons, okay? So if we go back to our slide here, so many of you should be familiar that elements are neutral, right? Okay, so if elements are neutral, then they must have the same number of electrons and protons. So not only does the proton number tell us the number of protons, atomic number tells the number of protons, it also tells us the number of electrons, okay? Because for you to have a neutral atom, the negative charge must be equal to the positive charge, yeah? So if we take a look at boron, for example, how many protons does boron have? So yeah, perfect. Boron has 5 protons. How many electrons does boron have? Yeah, so there's also 5 electrons. So because a proton has a negative charge, we have 5 negative charges. So we'll say it's so because the proton has a positive charge, we get 5 positives from the proton. And because the electron has a negative charge, we get a 5 minus from the electron. And as we know, these two charges are going to cancel out, and therefore your boron is a neutral species, okay? So all atoms in the periodic table are neutral because they have the same number of protons and electrons. So say the proton number not only tells you the number of protons, but it also tells you the number of electrons in your atom. Okay, that makes sense. Okay, so let's talk a bit about other stuff in action. So let's quickly talk about the metals and non-metals. Do people know where the metals are found and where the non-metals are found? Any ideas? So if we draw this, metals are on the left, perfect. Metals left, non-metals right, yeah. So hopefully you guys have seen this staircase thing. So these are all the metals, non-metals, and these are all your metals, okay? So it's quite easy to tell which is a metal and which is a non-metal just by looking at your periodic table. And yet there's a lot more metals than there are non-metals. Okay. Perfect. Lots of great answers. Well done, guys. Okay. So now let's look more into the periodic table. So how are these elements arranged? You've got your periods that are horizontal rows, and each period contains the same number of energy levels, okay, or shells. And we're going to look at electronic structure in our next lesson tomorrow. We're going to come to some of that. So all of these have the same number of energy levels, okay, and these are called a period. Yeah. So then, what other way is the periodic table arranged? We also have the groups, okay? So your vertical columns, they're all called groups. And does anyone know what the group number tells you? These numbers at the top. So these numbers at the top are your group numbers, okay? And they're really important. They tell you a lot of information. Yeah, perfect. So it is the number of electrons in your outer shell. Brilliant, okay? And so elements in the same group tend to have similar chemical properties, yeah, because they have the same number of electrons in their outer shell. Okay, so yeah, so it's really important to remember that periodic table is arranged in groups, and you've got your periods that go horizontally. Okay, brilliant. So let's have a go at some questions then. So for A, what is the number of protons? 8, perfect. What's the number of electrons? So we've got 8 protons and 8 electrons, as this number tells us. And how many neutrons do we have then? Yeah, brilliant. 8 neutrons, because we do 16, take away 8, which is equal to 8, because this is the mass number, which is the number of protons plus neutrons, and this is your number of protons. Okay, so what about B? Number of protons is 15. Yeah, great, lots of correct answers. Perfect. Yeah, brilliant. 15. Number of neutrons are what? Some of you guys have already said that. Yeah, perfect. So if we've got 15 protons, we've also got 15 electrons, as they are always equal. And yeah, and the number of neutrons are 16 indeed, because we have 31, take away 15, which is equal to 16. So do you have any questions on the periodic table or atomic structure? Any questions on this part? Why do we call the protons the atomic number? So it's just a formality. The atomic number is, yeah, it's called, so you can either call it the proton number or the atomic number. And it's the atomic number because each atom has a unique atomic number. You don't ever have an atomic number that's the same. So your atom's kind of labeled by this number. Okay. What else? This one. Yeah, so this is on all papers, as this is like such a common topic, and it is like frequently visited in all other parts of the chemistry course. And the top number, which top number are you guys referring to? If it's this top number, it's called the mass number, and that's the number of protons and electrons. Okay. So how is it 15 electrons for this one? So the electrons is equal to the number of protons, right? So the mass number is equal to protons and neutrons. Yeah, whilst the atomic number is equal to the protons, which is equal to the number of electrons, okay? So if you've got 15 protons, then you've got 15 electrons. Whilst to find out your number of neutrons, then you do 31, take away 15, which is equal to your 16. Okay. Do electrons count towards the overall mass of the atom? Great question, but no. As we saw previously, the relative atomic mass of a proton and a neutron was 1 each, whilst the relative mass of an electron was 1 out of over 2,000, which is the same as saying 0 in our, we can think of it as just 0. So is the atomic number always on the bottom and the mass number at the top? For the periodic tables that you will use at school, then yes, typically yes, but you will always have it labeled. As you can see here, you have a key, and then you can use that and that tells you what is what. So here it's told you that the bottom number is the atomic number, which is the number of protons. Told you that the top number is relative atomic mass, which is protons plus neutrons. So it will always have a key. Each periodic table has a key that tells you what it means. Different mass numbers. Okay, great. So someone has brought up isotopes. So what is an isotope? An isotope is the same element, so the same proton number. So let's take lithium, for example. So if we have this one here, we've got 7 Li. An isotope would have the same number of protons, but a different number of neutrons. So for 7 Li, how many neutrons do we have? Yeah, so for 7 Li, we have 4 neutrons. For 8 lithium, how many neutrons do we have? Brilliant. 5, exactly, okay? So for same isotopes, we have the same element, which means we have the exact same atomic number, However, the number of neutrons can change, therefore the mass number can change. Perfect. Okay. Is it actually one? Sorry, what's my part? So 8 electrons, 16 take 8. Do the periods show on the number of electrons? Yeah, exactly. Perfect. So yeah, so an isotope has the same number of protons, different number of neutrons. Exactly, Hannah. So we'll get on to ions another day. So why 15 electrons? So for phosphorus, right, if we look at it, so the bottom number is our atomic number, which is our proton number. Yeah, and as we've said, our proton number is equal to our number of electrons. Okay, so that's why, because we have a proton number of 15, we also have 15 electrons. Okay, so the mass number is just the number of neutrons and protons in the nucleus. We won't be covering electrolysis. Okay, so let's carry on to, so this is for year 10 and year 11. This is like the start of the course. So it's really good to have a good understanding of this part as it comes up quite commonly. Okay, so let's move on to chemical equations then. Okay, so chemical equations. We have our reactants on one side, and then we have, so our reactants are always on the left-hand side, and they go to form our products. Okay, quick question, what is an isotope? So the same element has the same number of protons, but different number of neutrons. So therefore it has the same atomic number, but a different mass number. Okay, so let's get back onto our chemical equations then. So reactants are on the left, products are on the right. And the atoms on either side of the arrow must always be balanced. Okay, this is really important. So firstly, you could have a word equation like this. So hydrogen plus oxygen forms water. Or you can have a chemical equation where you use the chemical symbols from the periodic table. Okay, so in this case, we have hydrogen coming together with water to form, coming together with oxygen, sorry, to form water. Okay. Yeah, we're going to be doing balancing now. Is this for all exam boards? Yes, this is you need to know this in all chemistry GCSE. What is the arrow that points in 2 directions? So I think that you're referring to an arrow like this, and that means it's in equilibrium. Okay, so this is much further down the line. But yeah, an arrow like that means the reaction is in equilibrium, so it's going both forwards and backwards at the same rate. Okay, so we must have them balanced. So if we have a certain number of elements on the left side, it must always be the same as the number of elements that we have on the right side. Okay, so this one's of course already balanced. However, let's see how would we balance this equation. Okay, so we start with H2 plus O2 goes to form water. Okay, so now the way I'd recommend doing it is writing down what elements you have underneath and counting up the number of atoms that you have. So can anyone say how many hydrogens do we have on the left-hand side? Yeah, you've got 2. Brilliant. And how many oxygens do we have on the left-hand side? Yeah, Yeah, we've also got 2. How many hydrogens do we have on the right? Yeah, brilliant. We have 2. And how many oxygens? Just the 1. Okay, so, oh, sorry. So we've got 1 hydrogen and we've got 2 hydrogens and 1 oxygen, okay? So this is definitely not balanced, as look, you've got 2 oxygens on the left and only 1 oxygen on the right. So therefore we can say they are not balanced, okay? So how will we start? Let's start by trying to balance our oxygens, yeah? So how can we balance our oxygens? We can add a big 2 in front of the water, okay? So now if we count up, how many oxygens do we now have on our right-hand side? What is it? Oh, it's now gone to 2. So the oxygens are happy, okay? Because they are now balanced. However, now we need to recount the hydrogens on the right-hand side. How many hydrogens do we have? 2 times 2 means we have 4. So therefore, the hydrogens are not happy. So we need to balance our hydrogens again. How can we get to 4 hydrogens on our left-hand side then? So if we add, what can we do? We add 2 in front of the H2. Exactly, perfect, great input. So yeah, we get to that answer. And now we can change this to 4 as 2 times 2 is 4. Okay. So the difference between chemical and symbol equation, they are the same thing. So chemical equation, so the difference is between a word equation. If they're like, can you please write the word equation, then you must give this equation, okay? So written out, and then otherwise you can always use these equations unless they specifically say, please use the word equation. So this is both a chemical equation and a symbol equation. Okay. So let's understand this a bit better now. If we look at this, so what does it mean to have H2O? How many hydrogens do we have in our chemical formula? Yeah, exactly, okay. So that means we've got, our chemical looks a bit like this. So we've got 1 oxygen and 2 hydrogens, okay? So if we go back to our previous page, you might be tempted to instead of adding a 2 in front of this and balancing it this way, you might be tempted to just add a 2 here, right? Is this correct? Could this ever be correct? No, exactly, okay? So when you add a 2 here, you're changing your chemical, okay? So you can never balance a chemical equation by adding small numbers or changing the small numbers of a chemical equation. You must always put a number in front of it, okay? So you must always use big numbers, always add 2. And of course, 2H2O means that you have 2 of these things, which means you have 2 hydrogens, so that becomes 4, and 2 of the oxygens. So that's where each of these comes from. Okay. So it's really important to never change the little number. That is not how you balance equations. Yeah, exactly. It changes the entire chemical. Brilliant. So you should never touch those small numbers. It's really, really important. Okay, so should we have some questions to practice then? Yeah. Let's do some questions and see how it works through. This is a lot like algebra. Yeah, perfect, Max. This is a lot like algebraic equations. You can kind of think about it in terms of factorizing. Brilliant. Great idea. Okay, so now let's try some practice questions. So firstly, let's write down the different elements that we have in our equation. So how many potassiums do we have on the left? So yeah, great. I can see some ones coming through. Brilliant, okay. And on our right, we have also 1. So therefore, our potassiums are happy. Okay, what about nitrogens? On the left, we have, yeah, good. We have 1. And on the right, we also have 1. Okay, so they're happy too. However, what about our oxygen? So on the left we have 3, and on the right we have 4. Okay, so these are not happy, angry. Okay, so let's think about where should we start? So we need to somehow balance our oxygens. However, it's a bit tricky. So let's start by adding a 2 in front of this. Now, how many oxygens does that give us? How many oxygens do we have now on the left side? Yeah, brilliant. We've now got 6. Okay, so we still haven't balanced it. And how many nitrogens do we have? The nitrogens changed to 2. And so does the potassium. The potassium also changed to 2. Yeah. Okay. So therefore, we know, let's try and fix the potassium and the nitrogen first. How can we fix that? Because now they're not balanced. They're sad because it's 1's on the right side. Yeah. So we're going to add a 2 in front of this one. Brilliant. Okay. So now we know that how many potassiums do we have on the right? We're happy. We've got 2. How many nitrogens do we have on the right? We're happy. We also have 2. And how many oxygens do we have then? Can people tell me how many oxygens we have on the right? Yeah, exactly 6. Okay. So this was actually quite a tricky question, as 4 and 3 are quite hard to balance. But look how we did it. So now everything is happy as all the atoms are equal on each side. So it's always really important to double check these kind of questions. Always double check how many of each atom you have on the left and on the right hand side. Okay. I just read some questions. Is there a method that always works for balance equations when they get harder? It's, to be honest, I think with balance equations, it's quite a lot of trial and error. And it's to do with trying like this whole thing. So starting, say, here on the left side and making 6, and then trying to work out the next ones, how to balance the next ones. But otherwise, I say it is quite a slow process sometimes. How did the second one become 6? So what do you mean, how did the second one become 6, Kathy? Is it how did we get 6? How do we have 6 oxygens on the other side? Yes, okay. So if we count them up, right? So how many, in this chemical formula, how many oxygens do we have on our right? 2, exactly. Yeah, if you have multiples, you should simplify them down. So yeah, exactly. So we've got 2 oxygens in this chemical formula, and we multiply the 2 oxygens by 2 because we put this big 2 in front, okay? So now, therefore, from this part, we have 4 oxygens, and of course, from this part, we have 2 oxygens, which adds up to give us our 6 oxygens. I thought we would have 8. Okay, so it probably would work, Max, if you say simplify it afterwards. But how many marks would this be? It would probably be 1 mark or 2 marks max. They don't really give you that many marks, but the more you practice balancing chemical equations, it gets much easier and much faster. Yeah, you do always multiply the smaller number with the big one. Yeah, perfect. Okay, because that's what I was trying to show with the oxygen, right? So in our oxygen example, where is it? So you've got this chemical formula. Yeah. As soon as you put a 2 in front of that, it's like saying you have 2 of this. Okay. So that's why you multiply the small number by the big number on the outside. So now you've got 2 of these molecules, and that's why we have 4 hydrogens in total. Does that make sense? What about balancing with those charges? We won't be covering that today. Okay, so let's try another one then. Okay, so this one is probably slightly easier. So once again, let's start with our writing down how many elements of each. How many elements of lithium do we have on the left? 1. Yeah, on the right we have, is H2 a covalent bond? Yes, it is a covalent bond. What about oxygens on the left? 2. Yeah, what about oxygens on the right? Yeah, okay. So how are we going to balance? Where do we start then? So if we want to balance the oxygens, where you can just put a 2 in front of the lithium. Yeah, in front of the lithium oxide, sorry. Brilliant, okay. So then our oxygens are happy because how many oxygens do we have on the right? We have 2. However, oh, so however, how many lithiums do we now have on the right? 2 as well. So our lithiums are not happy. And as many of you guys have said, we do put a Lith2 in front of the lithium on the right. And that equation is perfectly content. Yeah. Great input, guys. Lots of good answers. Okay. Let's see, I think I've got one more example. Okay, so let's give this one a go. Where should we start with this one? So once again, I'd say write down how many of each thing you've got. So yeah, we've got 1 aluminium on that side. How many aluminiums do you have on the right? So we've got 2 aluminiums. What about the oxygens on the left? We have 2 oxygens and we've got 3 oxygens on the right. Okay, so now let's try firstly balance our O3 and O2. These are probably the hardest thing. So when you have something like this, the best approach is to find a common multiple of the 2 and make it that, okay? So what's a common multiple of 2 and 3? So that would be 6, exactly, okay? So we're gonna try, so how can we get to 6 oxygens on the left and on the right? So to get to 6 oxygens, we're gonna put a 3 in front of the O2 and we're gonna put a 2 on the right. Brilliant, great input, everyone. Okay, so now we know that our oxygens are happy because we have used the common multiple. So we can write 6, 6, happy. Okay, what's happened to aluminium on the right-hand side? How many aluminiums do we now have on the right? Yeah, exactly, okay. Brilliant to everyone who said we've got 4 aluminiums on the right. So therefore, how are we going to balance this then? So we want to get 4 aluminiums on the left. So we're going to put a 4 in front of this aluminium. Okay? Yeah, brilliant. Okay, so now 4 aluminiums, tick. The aluminiums are also happy. Okay, so yeah, I'd probably recommend, if so you've got like this one when it was tricky because we had 2 oxygens at the start and 3 on this side, to find a multiple of these 2. Start by doing that. As of course, it's really easy to balance atoms that are just 1, because then you just put the whole number in the front of it. Okay, that makes sense. Okay, so last one I think for balancing equations. This one's slightly longer. So also I wanted to ask people, what does it mean when you've got the 2 outside the brackets? So in this chemical formula, how many oxygens do we have? Do people have any idea? Yeah, great. And how many hydrogens do we have? Yeah. Brilliant. Okay, perfect. Great input. Lots. Multiply everything inside the brackets by the outside number, exactly. So it means that for each Mg, you have 2 OHs. That's why you've got 2 oxygens and you've got 2 hydrogens in that chemical formula. Yeah? Okay, so should we try this balancing this equation? It's slightly ruined it. Let's put the H2 on this side, but just add H2 on this side. And we'll ignore this H2, okay. So what elements do we have? We have H, N, O, and Mg. Okay, we've got lots of elements this time. So it's quite a challenging one. Okay, so how many H's do we have on the left side? We have, yeah, brilliant. To everyone who said 3, exactly right. So we've got 3 H's on the left side. How many nitrogens do we have on the left? 1. How many oxygens do we have on the left? 5. Yeah, great. And magnesium would. So it's 5 oxygens because we've got 3 here and we've got 2 from this part. and magnesiums would be 1. Perfect. Okay, now let's look on the right side then. So magnesium, so let's start with the hydrogens again. How many hydrogens do we have? We have 2 now. How many nitrogens do we have? Yeah, we've got 2 nitrogens. How many oxygens do we have? That's quite a lot of oxygens we've got. 6. Okay, so it's actually, we have 7 oxygens. So can you see here, this gives us 6, but then there's also 1 oxygen from the water. So that's why there is 7 oxygens. And magnesium, once again, is 1, okay? So magnesium is the only happy thing. So with this one, where should we start with our balancing? So what I recommend is start by balancing your nitrogens. So we balance our nitrogens. How are we going to do that? We're going to put a 2 in front of our HNO3. Now we have 2 nitrogens, so the nitrogens are happy. And let's check, what does that mean for our hydrogens and our oxygens? So now we're going to have 4 hydrogens, and we're going to have 8 oxygens. Yeah? Can everyone see that? Do you have questions on this part? What does the brackets and 2 outside it mean? So yeah, you multiply everything inside the brackets by 2. So this for double or and triple site? Yeah, it's for both. This is like really common to all past paper questions. Why should you start with nitrogen? That's probably the easiest one to start by balancing. So you see that nitrogen is 1 to 2. You could just multiply that by 2 to fix that one and see how it affects the rest of the atoms. Okay. So how do I get 8 oxygen? So we put a 2 in front of this one, right? And as you can see, here we have 3 oxygens. So 2 times 3 is 6. So from this formula, we have now 6 oxygens. And of course, from this formula, we also get 2 oxygens, okay? So that's how you got your 8 oxygens. Does that make sense? Yep. Okay. So now let's finish it off then. So now we've got 8 oxygens and 4 hydrogens on this side and only 2 on this side. So how can we balance the hydrogens now? If we put a 2 in front of our water, we're going to get 4 hydrogens. So now the hydrogens are happy. And now let's count up how many oxygens do we have on the right side now? Does anyone have any ideas? How many oxygens do we have on the right? Yeah, exactly, okay? So we do have 8 oxygens on the right, okay? Because you've got 6 from this part, because we've got 3 oxygens inside the brackets. 3 times 2 is 6. And then we've also got 2 times 1 oxygen, which gives us another 2 oxygens, okay? So therefore, we now have 8 oxygens on the right, okay? So does anyone have any questions on this formula? As I think next is, oh, okay, I think we'll leave this one. Yeah, after this, we're going to do a Kahoot. So do people have any questions on, any more questions on balancing equations? So it's only 4 hydrogens on the left, as we've got 2 hydrogens from this part, and then we've got 2 hydrogens from this part. How can you add more elements on the right side? What do you mean add more elements? I haven't added any new elements. And also, when did you add the H2O at the end? So that's part of the reaction. Sadly, the computer had put the H2O here. So I just moved it. So it hadn't ordered the formula correctly. So in this reaction, you also produce H2O as a product on the right. Okay. Okay, can you send me videos? So let's see. Divide them into group 4. How do you know if they lose 4 electrons or gain 4 electrons? So that's kind of, it depends on more what the question is. That's not really very, so with group 4, usually that's not really used in GCSEs, as they are, some of them are metals, some of them are non-metals. But if it's a non-metal, then it will lose, no, then it will gain the electrons. But if it's a metal, then it will lose the electrons, okay? So that should be your general rule. Metals gain electrons, non-metals lose electrons. How hard to balancing equations get? They get quite tricky, but they are always manageable. You're always able to solve them. So there are 8 oxygens. So there are 8 oxygens, because if we count up the oxygens on the right here, you can see, so in this formula, we have, from just this formula, we have 6 electrons just in here, because we've got 3 oxygens inside the brackets, and we've multiplied the bracket by 2, okay? So that's where the 6 comes from. And then we get to 8 oxygens, because to balance our hydrogens, we add a 2 in front of the water. So then 2 times 1 oxygen gives us 2 oxygens. Okay. Okay, so let's get to Kahoot. So we're going to do a Kahoot, and then if we have time at the end, we're going to do some past paper questions on this topic. Okay? Let's get Kahoot up then. Dun, dun, dun. Okay, so if people want to load up the Kahoot website then, and then I'm going to get the code up. So let's So if you just want to go, so to get onto Kahoot, you search up the Kahoot website on a phone or on your laptop, but it's probably best on a phone. And then you add in this code, okay? And so we're just going to wait for people to join it. But if you guys don't have a phone or can't access Kahoot, just write down your answers, and you'll be able to see the answer at the end. And you can just check it as we go along. Yeah. So there's a couple of questions like, what's the best way to revise for chemistry? There's actually going to be a revision webinar soon on the 28th, if you guys want to attend that, and that will be discussed that day. Oh, sorry, I forgot. Just put the code. Can you everyone see the code? So we'll give it another 10. So we're gonna do the Kahoot until it ends, and then if we've got some time, we're gonna go over the Kahoot answers and also some past paper questions if we have time. So we'll give it another 10 seconds and start the Kahoot. People still joining. Okay, let's start then. So chemistry quiz 1. So how many electrons are in silicon? So here's your silicon. Okay, how many electrons are in it? So please write down your answers if you can't access Kahoot. Okay. Seconds. If everyone wants to click here. So once everyone submitted their answers, it will move on to the next question. Okay. So well done to everyone who got it right. Really good. We'll go through why it is 14 in the PowerPoint. Okay, well done to Vid. The next one, how many neutrons are in aluminium now? Okay. Just a couple answers left. Then we can. Everyone's just press something. Brilliant. So, oh, okay. So it was 14, and we're going to do that. Go through it. See? Well done to Boris Johnson. So, what is the charge and relative mass of an electron? Yeah. Great. Almost there with the answers. Last 10 seconds then, if you haven't answered. Okay, brilliant. Ooh. So yeah, so the charge of an electron is always negative. Charge of the proton is positive. Ooh, well done to Puem. Okay, number 4. So now we need to balance this equation. How are we going to balance it? So think about how many hydrogens there's on the left side, how many chlorines are on the left, and how many hydrogens and chlorines are on the right. And make sure that they are equal. Get us the last 15 seconds, keep answering. And who hasn't, well done to everyone who has got an answer. Okay, so yeah, oh, well done. Most of the people got it right. Brilliant. Well done. Oh, done to you guys. So how many outer electrons does an element in group 6 have? Don't have much time to answer this one. Brilliant, well done. So group 6 tells you that there is 6 electrons in its outer shell. It tells you the number of electrons in the outer shell. Well done to PUM for keeping their top position. So number 6. So atomic number is the number of in the atom. Okay, yeah, well done. So atomic number is the same as the proton number, so it's the number of protons in the atom, not the number. So it's equal to the number of electrons, but it's not equal to the number of protons and electrons. Well done, Izzy. So last two questions then. Number 7. So an atom has 30 protons and 40 neutrons. What is the mass number? Yeah, well done to everyone who put 27. Of course, the mass number is number of protons and neutrons together. Oh, well done, Leah. Okay, and last one. Atom has an atomic number of 9 and mass number of 19. What are its numbers of protons, neutrons, and electrons? What did the atomic number tell us? Okay, well done. Sorry, that one did not have much time to give in. Okay, so now let's go to see who's the winner. Then we will do, we'll go through the questions to understand all the answers. Well done to Joanne, Izzy, and Ewan. Well done to you three. Great work. Okay, so let's go back and just quickly talk through them. So question 1 was the number of electrons, I think. Yeah. So the number of electrons, of course, it's the same as the number of protons, and the proton number is the bottom number. So 14 protons, therefore we have 14 electrons. Okay, so next one. So this one was number of neutrons. So we said that the top number was the mass number, which was the number of protons and neutrons together. The bottom is the proton number. And so therefore the neutrons will be 27, take away 13, which is equal to 14. Yeah, if you have any questions on the questions in Kahoot, please please ask them. Yeah, we do end at 12. So then what was the relative charge of an electron and relative mass? Yeah, so the electron is the negatively charged particle, and it's got a relative mass of 1 out of 2,000, or you can say it has a relative mass of 0. Both are correct answers, okay? So it has a very small mass compared to your proton and your neutron. Okay, so balance the equation. Yeah, so if we counted up how many hydrogens, how many chlorines we have on each side, this was actually a lot more simple than the ones we were doing. So we have 2 hydrogens on that, 2 chlorines, and only 1 of each on this side. So of course we just need to add a 2 in front of this, a big 2, so we get 2 hydrogens and 2 chlorines. Okay. So then we had how many outer electrons does an element in group 6 have? Yeah, brilliant. It is 6 because the group number tells us how many electrons it has in its outer shell. So if we want to have group 7, how many electrons does that have in its outer shell? We would say 7. Okay, group 3 would have 3 electrons in its outer shell. Okay, so the group number tells you the number of electrons in the outer shell. Okay. So the atomic number is the number of protons in the atom, okay? So remember, the atomic number, also known as the proton number, tells you the number of protons in the atom, which is also equal to the number of electrons, okay? Although it's not anything else. Okay, so then the atom has 13 protons and 14 neutrons. What was its mass number? So what was a mass number? That was the number of protons plus neutrons, which is 13 plus 14. So that's how we got 27 exactly. Okay, and lastly, which we didn't have enough time for. And lastly, we had our question that said, sorry, the questions got a bit mixed up on this, so we'll start there next time, then we'll finish up here. Yeah, well, thank you everyone for attending today, and tomorrow we'll be doing the revision course at 11 o'clock again. So I'll see you then, and have a nice, lovely Monday. Bye. Goodbye.